Yeah, this we completed, right? PCIe P2P transaction, which means one endpoint to another endpoint. If we wanna have a conversation to transfer the traffic, either TLPs or DLLPs, then how the transaction will happen? Okay, what are the path that we will see? Okay, this is requester. It is requesting some data. Okay, this endpoint. So what it will send is this will send MRD, this green on MRD. It will go to the switch B. Switch B will forward it to the switch A. It will go to the switch A. Switch A will forward it to the RC. RC will route it to the switch C. So switch C to it will go switch. This address is for only endpoint. This endpoint. That's why it will perfectly, though this endpoint it will never go. It will go to only this because of unique addresses. Completer. What completer is? Completer will ensure with the completion data. This is the memory read transaction, right? So this is an unposted one. So what will happen is completer will return a completion with data, CPLD. PCIe data link layer. What? Yeah. Yes, someone. That is simply a bus, customized bus. To have a conversation between RC as well as that multi-cores, will use FSB. That is a bus. Okay. Data link layer, what it will ensure means, first and foremost thing, what it will do, we have discussed this already. First and foremost thing, data link layer will ensure ACK. That is very important. Whether it is that given transaction has success or failure. Okay, success is indicated with the ACK, failure is indicated with the NAC. That's the first thing. Okay, and that too, what it will do is till Gen 5, what it will do is simply it will auto retry. So it will go to the whenever it will detect first. Okay, whether there is a error in the data, then it will automatically uh, it will endpoint will automatically send a packet stating that retry again, that for the completer it will send stating that again retransmit the data whatever you said earlier of this sequence numbers data. Okay, sequence number is 12-bit one, right? So 2 power 12 is 4K. 4K transactions are possible. So it will go there in their retry buffers. Okay, each and every packet which is going from device A to device B will be stored until and unless it gets either success or failure comes. If failure comes, again this same data they will put it onto the link. That's as simple as that. It will ensure the data integrity with the LCRC, that is CRC, and one more topmost layer in TLP we have ECRC. That is optional. Still, that is present. It will give one more layer of what we can say. One more top layer of abstraction level of error detection. Yeah, I forgot this. This is very very important. FCPs, flow control pockets. See, the who will assign the FCPs credit flow credits? Who will assign? It will be always assigned by the RC to the endpoints. It will tell like, uh, hey endpoint, this is your credits. Whenever that secure boot happens, at that time only RC will comes into the live. Then or else if you do anytime POR, power on reset, still it will come out of that chip will wakes up, and it boots up, boot loads by OS. After that it comes to the live. Then it will allocate the particular number of credits for different endpoints. So what it will ensure is, whenever it is doing any transaction, at that time those credits will be consumed. Those consumed credits, that information, okay, that either requester or completer should broadcast it to the RC, that at current present of time how many credits it present. Based on that, RC will give access to that to particular endpoint for that. If the credits of that endpoint have at least more than, okay, at least more than what requester is requesting the resources. So that kind of validation will be done at the data link layer. That is very very important. Data link layer will ensure. Apart from that, what it will do, it will take care of the power management. See, for example, if your link isn't transferring the data, for example, we have some fixed amount of time. That time we'll call it as timeout. That will be taken care by the counter. Okay, counter will count incrementally. If no, after reaching that timeout duration, still it hasn't have any activity on the link, then what it will is, it will report to the us stating that, hey boss, please make it that into low power states of LTSSM. So what it will do is, first it will make it to LOS, after that LOP, L1, L2, L3. Like this, there are low power states are there. It will go into that states. Again, see, to go into that states, yeah, again whenever there is a request comes from any device, related to, whenever it is attached or detached, or if anyone raises the request which is already present in the link, then again it will route back it to the L0. That is active state. In active state only, both TLPs as well as DLLPs transfers will takes place. Hello, are you people are okay with this? Venki, this is my first class. No, no, previous one link I shared, YouTube link shared by Tilak. Okay, in the group. Please go through that. You'll get some idea. So you people got some idea right now. I already in my previous sessions I ensured that the how many for each and every transaction, how many credits it will allocate and deallocate and will validate based on qualify checks, that I have discussed already. Okay, what sort of credits it will allocate. So power management packets, vendor expansions. See, vendor, if we want to expand it to the cache, this is cache related things. If they want to expand, then he will expand through this. Uh, Even to extend cache, mostly we'll use the CXL. Okay. So see, this is this blue color one is DLLP. Okay, this whole DLLP. This is 6 bytes, and SDP start of DLLP, end of DLLP. So total it will become this will be there in the uh, physical layer. This will be there in the data link layer. Transmit order first to SDP will go, after that DLLP, CRC, after that end will go. This is the direction of transfer of the data. PCIe flow control, very very important. PCIe flow control will be taken care by the data link layer with the help of credits. Okay, see here, point to point, not end to end, just point to point communication, how it will happen. See here we have the data link layer. See, this white portion is available space. Receiver have this VC buffer, virtual channel buffer. In that white space is available buffer. Remaining was completed. Our request should be less than or equal to the space of that empty space. Otherwise, it will validate that it will. There are two scenarios. It can simply deny the access, or it will wait till the request comes with some higher what we call priority. Then it will wait until and unless it will get to some free space, so that after that it can grant the access. Flow control update loop. See, here step by step we need to go. Okay, this update loop will happen continuously it will happen internally. So what are the things it will go? This is our data packet. What is meant by data packet? Simple. TLP, which is encapsulated in DLLP, that is our data packet. In the data packet, it is going on a uh, this is the path of data. Okay, it will go to RX buffer, then it will simply go out of that data packet. In that, what are all checks it need to check? Okay, first it will check credit check. This is the first instance. Okay, flow control gating logic will be there here, some logic. What it will check is a credit check. How many credits what that requester is consisting currently, that will be taken care by this. Okay, after that, through this it will report back credit consumed counter. Credit consumed, earlier how many credit were consumed. So how we will get that figure? Total credits minus the credits will be accessible by previous successive transactions. That sum, if we do subtraction, then you will get uh, how many credits got consumed out of total. Okay, then it will go to directly to this. If it is credits are not sufficient to serve the uh, give the service or grant access, then it will allocate. Okay, it will increment, allocate. After that, this allocation is there, but whether it is allocated or not, that information we don't know, right? That will be updated in FC update DLLP generator. It will tell that this many credits I have given, it is currently it can serve the purpose, like that. After that, it will go to FC update DLLP. FC update DLLP will decode, and credit limit, whatever earlier was there, that got updated new value. I think it is little bit tricky. Please have a glance to that thing. I'll come back after having a water. Venki, it is already there in the community. Please check with Deepika. You will get it. Okay, you people got some clarity right now. Hello. Okay. Yeah, PCIe have built-in RAS as well as QoS, quality of service. Okay, RAS means data integrated error handling. PCIe has RAS, reliable, available, serviceable. It will service. Okay, data integrity at LCRC and end-to-end at ECRC. This is option. Okay, virtual channel VCs and traffic classes TCs to support differentiated traffic or quality of service. Because see, some services will come at see, we'll go to Tirumala, right? If VIPs comes, we're also going general public. So those people will give priority, right? Here also, whomever having the priority, those will give special treatment. In theory, actually, this VCs and TCs are 3-bit size, right? 2 power 3, 8 combinations. So availability to different levels of service for a packet, different TCS will be 8 TCS and 8 VCS are available. But theoretically it is okay, but to build that many PCs and VCs hectic job. It will consume a hell amount of this resources in die or a chip. So at most only one VC, one TC to implement itself will struggle a lot. That is the reality. Okay. Yeah. What is meant by error? What is the source of error? The source of error is obviously noise. The signals are going, okay, the lanes are going in a channel. Always channel tend to be lossy. So there you will encounter a there you encounter a what we can say, some noise due to that. Some small spikes will come, very short duration spikes. Okay. uh, at the receiving at the receiving end. Okay, while sampling for a bit. Okay, because of this noise, I'll use the technical word called glitch. So because of this glitch, it may give wrong data, but still we have CSA checkers. CSA checkers will ensure that there is a uh, there is a error or not. That's called detection. Okay. And see, it depends upon Hamming bound. Okay, those detection and corrections, how many bits it will be, Hamming bound decides. But your architect of your designer will decide that the what kind of how many number of bits it can detect and how many number of bits it can uh, correct. It will be decided by him through the cost budget analysis. If we are going for very good architecture, costs will be more, and time also it will fetch us more. So most in general we will use, we will call SECDEC, SECDEC, which means single error correctable, double error detectable. You people remember that. And see, some errors can be correctable, okay, in DLL automatically. Okay. Example, LCRC error, automatic DLL retry. There is no forward error correction until PCI Gen 6. In PCI Gen 6 only, we have FEC. Till Gen 5, what we used to do is automatic DLL retry. Whenever we will encounter a error, it will discard the packet and it will ask to retransmit again. That's all. But see, I told you channel is lossy. What does it mean? See, for example, same number of environment that attributes are present, the ambience is same. So multiple times if it comes, then how my duty will decide, who will decide that the architect of the designer, okay, he will decide that the how many times that kind of error scenarios come, still it will ask creator. After that it won't do continuously that will degrades our performance like hell, like anything. So what he will do, because of that he will ensure that the few times or 3 or 4 times 5 times he will fix. After that what he will do, he will entire link train, he will train the link. Okay, that's it. And see, uncorrectable errors, fatal, not fatal, these we cannot correctable. Okay, these things should ensure that the some what we can call special treatment is required. Cannot do cause this deadlock or reset. See, recovery mechanisms are outside the spec. Those are like RTL design. It is in RTL designer's hands. Example, failure for a HA. Yeah, we'll come to acne, how it will happen. Okay, this is between point to point. I'm discussing about point to point. From transaction layer we will get here TX. Okay, here what will we are giving it to the transaction layer of device 2. This is device A, this is device B. So what will happen means, obviously here we have a TLP assembly will happen in transaction layer. For that what we will overhead will be given in DLLP. TLP will be embedded with or encapsulated with the sequence number plus LCRC. Okay, see LCRC, this entire packet we will store it in a replay buffer. Why the purpose of replay buffer means, if my DUT discards and asks to retransmit, then we need to send this again assembly of packet, and we cannot do that, is hectic job. So we will store it here and we will send it back through the mux. We will send it to the transmitter, so it will go into the link. So it will go to the dmux, error check will happen. After that DLLP ACK. Okay, if it is ACK, okay, well and good, it will go to the mux, to the link dmux, ACK is coming. So here the packet which already went and got the ACK got nullified, that will be removed, that will be flushed out. Someone raised a hand, right? I got some sound. Okay. So if it is NAC, then it will retransmit. So at device B sequence number and LCRC we will discard. We want TLP only. The TLP will extract. Obviously, simple. See, PCIe physical layer. See, while the lanes are not tightly synchronized, there is a limit to have lane to lane skew. What is meant by skew? The difference of delay between lane to lane in a link. For example, we are taking here four lanes. Okay, here are many. Assume only three lanes. Okay, these are the differential signals. Okay, TX plus TX minus, or RX plus RX minus. So this will be like this curly way. Why? Because our signal should go like this, straight line. If your wires are circular in dimension, your signal will go in a straight line. That's what we want. This is going, this is coming down. So the wire should be in circular fashion. So here this lane and this lane, the timing delay is called skew. that we need to deskew at the receiver end. That's our job. The skew of 28 6 nanosecond for 2.5 G 58 Gs, which means Gen 1, Gen 2, Gen 3. These are the figures. Okay, that much skew we can expect. For that, what we need to do, I already told you people that we will introduce the zero delay elements. Those will ensure that the it cannot anticipate the future, but it can slow down which is going a faster one. That's all. So it will synchronize that too, like that. PCIe order set structure. See, what are the structure of PCIe have? PCIe have this is transmit order. This is comma. Comma is a special kind of symbol. Okay. After that, identifiers we will set of identifiers will send. What are these identifiers means? Different types of identifiers will be there, that we call it just trained sequences, TS1 and TS2. Okay, one com see initially one com symbol plus 15 TS trained sequences will send, used to deskew the between the lanes adjacent lanes, that skew should be nullified. Skip one com plus 3 skip identifiers used to recalibrate the receiver clock. Receiver clock we will extract by using the clock data recovery block. In that we will extract the clock and we will calibrate it with respect to the actual clock generation. uh, why do we use these fast training sequences means, these are for power management. For example, if it went to low power states and again whenever there is a request initiated by the any endpoint, then automatically this whichever is present in low power states, it should route back to the what will say route back to the L0 state, that is active state where the TLPs and DLLPs have a transaction traffic flow would be present. See, and one more important key players here are, okay, electrically ideal ordered sets, EIOS, electrically ideal exit order sets. Okay, these will ensure that the speed change whenever you wanna change the speed. Okay, 16 characters it have. Okay, 8 unscrambled bits, 8 unscrambled bits present in this electrically transmitted continuously when no data. Why still why do we need to transmit this? To make link active. Yeah, framing, we'll see. See, this is how it will go. First the com symbol will go, after that identifiers. PCI framing X1, which means only one lane is there in an entire link. In that, how it will happen, we will see in a microscopic way, so that you can map it to the X2, X4, X8, X16, X32. Even X32 is also present in the market, so you can map it that too. Okay, transmit order, time, reserved bit sequence number, data link layer. Okay, these things. STP frame symbol, physical layer will ensure this. These two will be reserved for sequence number, data link layer. Okay, and this red color will TLP structure, TLP packet it is. This blue color one is LCRC, integrity check, end framing symbol, physical layer. Okay, so now we were transmitting for X4, we are mapping it, but these things will be going, this dimension is telling like time axis, and y axis is time, and x axis is space, time space related. See here, lane 0, lane 1, lane 2, lane 3. Okay, if lane order space, for example, what will happen, instead of lane 0 to port 0, lane 1 to port 1, like that we will fix, right? For example, if it is lane you reversed the chip and inserted it by mistake. Instead of lane 0, lane 3 came, instead of lane 1, lane 2 came, like that. After that lane to lane 0, it came like that. Still it works. Okay, the PCI intelligent enough to identify it, that lane got reversed, and it will act like normal one. Okay, see here we have 4 lanes. Here, start of packet, end of packet. In between that, this is this color is for DLLP, this red color is for TLP. After that again DLLP, end. This color is for physical layer. Are you people following, or do you want me to brief once again, summarize once again? Please do tell me. Based on that we will go. Because it is a little bit tricky part. Hello. Okay, summarize once. Okay, Shravan, will summarize. Simply, data link layer, what are all the checks it will take care, and what are the functions it will do, those things only we discussed till now. Okay, it will check mainly data integrity through how ACNAC for reliability, and retry, ensure data integrity. Those steps we went step by step. Okay, you people got some clarity, right? Sajad, can you please once summarize the why, Suraj? Should we stop here? Oh, yeah. You are right. Oh, that way you told. Yeah, got the point. Okay, that's why. Actually, if you people are pinging in chat, I'm unable to get it. That's why I'm polling again and again. To simply to summarize, this will take care of data integrity and reliability. Only these two parts: reliability, availability, serviceability. RAS also obviously it is taking care. Quality of service. For example, a higher priority request comes, we need to definitely give first priority to serve that. Those things QoS will be taken care of. Only these things we discussed till now. Can we proceed, or what do you people are expecting? Can we proceed? Can we go ahead now? You people got some clarity, right? Respond someone so that I'll get some kind of conference to either go through or summarize, or we will stop it here and discuss interview questions like that. Hello. Yeah. What are you supposed to do? Yeah. Can we discuss interview questions now? Okay. Sure.